Relax. It's ASMR. Hello everyone. Well, today's video is going to be the first in a series. I'm not sure how many will be in this series. Hopefully, quite a few. But as I mentioned in my last video, I'm starting the adventure into having my own 3D printer. So I figured I would take you all along on this journey. And I want to make the disclaimer up front that this is my exploration of 3D printing up until this point. So I may not be a complete expert by any means at this point. I may look back on these videos and say, I didn't know everything. So this is not a tutorial, this is an exploration, and I wanted to take you along with me on it. So I hope you do learn some things, but take it with a grain of salt. This is mostly just to kind of have a journey together, enjoy learning new things. And to start off with, I thought I would talk about exactly what is 3D printing. I think that's a pretty good place to begin. So what I'm going to do is draw different parts of the 3D printer as I understand them now, at a very basic level. Nothing really super detailed, just to get the concept of what is going on when we are printing something in 3D. So that starts off with the 3D printer. And there's several different configurations, but basically what the kind that I am getting is an extrusion-based 3D printer. And that basically means that you have a print head, and at the bottom of that print head, there is a nozzle, and it looks something kind of like this. And at the top, you usually have a port and some sort of tubing that comes out of the top of the print head. And usually there is a fan somewhere in this print head, small fan. And it needs a fan because this gets very hot. It can get up somewhere between like 130, 150, 200 plus degrees. And the reason it needs to get so hot is because coming through this tube is a thin, small filament of some sort of material. Usually, it's some sort of plastic material, or like a polystyrene, a polyethylene, something kind of in that plastic family. And it is fed into the print head. It is heated up to a liquid, gooey, sticky consistency. And it is squirted out at the end of the print head. So, that material is then slowly built up in layers, and you can adjust the thickness of those layers one after another. It is stacked up, and the top layer squishes into the layer below it, and because it is sticky, it adheres, theoretically, there can be problems with that if you don't set up things exactly right. So basically, this printhead draws the shape in plastic. Now there's other types of things, like you can get filament that has like sawdust in it. So it's kind of like wood, but the sawdust is bound together by plastic type materials. So it has to be something that melts and then rehardens fairly quickly right at around a certain temperature. You don't want to get it too hot or it will be too runny, and if it's too cold, it just won't come out and it'll clog things up. So this does not just float in space. It has some sort of mechanism that allows the printhead to move in some direction, usually like back and forth. And you also have this supported on either side. By one or two rails on either side. Kind of drawing this sloppily right now. And these go up and down. So we have 1 dimension, 2 dimensions, and then the third dimension is taken care of by a bed or a plate at the bottom of the printer where the actual thing that you're printing rests. And that moves back and forth towards you and away from you. So that's supposed to be an arrow in perspective. So that is one way in which 3D printing is accomplished, and that is the type of printer that I am getting. Now sometimes you will have the printhead at the top, like this, and it moves back and forth like this, and it will move forward and backward like this. Let me finish off my whole thing here. And then you have the bed, and it moves up and down. And there are advantages to each one of these types. You also have some that are, instead of going back and forth like this, the printhead is suspended from 3, I think it's 3, maybe 4 different arms. And I've seen them that are circular before. So I'm going to draw this circular. And then you also have a bed that moves up and down. And then this moves in the basically back and forth and forward and backward positions based on these arms that shorten or lengthen so that this can move all over the place. And these are much more expensive, but they are a lot more accurate as far as being able to do really small detail things. So there's a few other variations of this. But this is kind of basically the different ways in which you can get this printhead to move in 3D space, because that is the goal. There's a whole nother type of printer that is called a resin printer, which we won't get into, but it basically uses a liquid resin and light and hardens the resin in layers inside of the liquid, and it slowly pulls the shape out of the liquid as each layer is hardened onto it. Completely different technology than this. Usually those are a little bit more expensive, and you're dealing with chemicals that are a lot more hazardous. So there are consumer models like that, but that's not what I'm getting into. At least not right now. This is a good introductory type of 3D printer. Just get your feet wet, just to understand the principles and what you cannot do with the materials. So another major component of a 3D printer is obviously the filament that goes into the printer. And they come on spools, and there are different thicknesses of them. The one I am using is 1.75 millimeters. And they come in all different types of colors and all different types of properties that might make one type of filament advantageous over another, depending on how you wanted to use it. And I'll make another video all about the details of the different types as far as their names. I don't remember them off the top of my head yet. But there's like a general purpose plastic that works pretty well around the house for making things that you might find useful as far as tools and little things like that, little figurines and statues. But it does not hold up well in the heat. So for instance, if you made something that you wanted to put in your car, you would not make it out of this material because it would melt in the car. Other materials are printed with a much higher temperature, so they can survive high temperatures like the car, but they also give off more fumes. Or there's some that are really rubbery, like you're almost printing like rubber band material, which are really cool, but they're very finicky to print. So getting to know the different materials is definitely part of this process, and one that I will be experimenting with. The other part of the 3D printer, and I'm just putting this up here, is the drive mechanism that basically pulls the filament out of the spool and pushes it into the printhead. Now you can have them like this that are separate, away from the printhead, and there's a specific term for that again, I do not remember. I'm learning. I'm not completely an expert yet. But then there is another type that sits directly on top of the printhead and provides a much more solid connection because it is constantly just pulling straight from the spool into the printhead, and that is called direct drive. Now the disadvantage of that is it increases the weight of your printhead. And this is the thing that's moving back and forth. And if you took a ping pong ball and held it in your hand and moved it back and forth, you'd be able to stop pretty quickly. But if you had a heavy steel ball or something that was really massive in your hand and you went to move it, you would constantly be overcorrecting as you started to try to slow that mass down. And so your actions be much more jerky. And the same thing here with the printhead. The more weight you put on here that you're slinging around, the more errors you can produce, because if you had, let's say these were your layers on the side, you would start to see possibly something like this. As it was having trouble slowing down the printhead. So to mitigate that, you would have to make the printhead travel more slowly. So then your print time would increase proportionally to that. Because these layers are sometimes quite thin to get a really nice, smooth print. You need to print a whole bunch of very small layers, and you get a much smoother result than if you were printing big, chunky layers. So it's the same as if you're printing a draft on a inkjet printer. It's going to just go quick and dirty just to get down the information on the page, but you wouldn't be printing like photographs or anything that was really, really highly detailed in that mode. So this is good for like prototypes, making sure everything fits together, or making sure everything works. And then when you really got it dialed in, you would print it at this higher resolution to get a really nice, smooth print that looked really sharp. So the difference is time. How long does it take to print? And I'm just beginning to learn all the different factors, because you can set not only how high and thick the layers go, you can also set, if we have the printhead here, kind of zooming in on it, and you had your filament that was coming in this way, and you got to the end of a shape, and let's say there was a gap, and you wanted to start printing this shape. Well, if you just keep on going, and this is still pouring out, you're going to get some droopy layers of filament called stringing that will connect these parts. They kind of look like spider webs. So another setting is called the retraction. And it is where the motors will pull the filament back up into the machine while it moves across. And then it will put the filament back through and start printing. There's another thing called the Z-hop, where you can take the whole printhead, and when it reaches a gap, it will go up a little bit. It will go over to where it needs to start, and then the printhead will come back down, so that it's not always printing straight across. This helps in also not getting drags and stringing across different parts of the model. Then you also have the temperature at which you print, and each filament has a specific temperature it likes to be printed at, anywhere from like 150, 130, all the way up to like 200, 250. I don't think they go much higher than that. But that's kind of the range that you're going to find things being printed in. And so these are nothing to fool around with as far as temperatures go. And they need cooling, but not too much cooling. Because what you want to have is, let's say you print this layer here, and it's squishy and hot. And then you print and you come back around and you want to print this layer. Well, you still want this layer to be a little squishy, but you don't want it to be completely squishy because you want these two to kind of stick together. But by the time you get up to this one, you want these layers to have cooled down significantly enough to hold their structure so that you're not constantly squishing down your shape and deforming it. So some print heads have a little fan that blows air onto the print head. And some of them I've seen actually have two. And I imagine that has to do with printing some very specific types of filament that maybe need to be very, very hot coming out, but they need to cool down pretty rapidly to be functional by the time you're ready to print on top of them again. So I haven't really gotten into that, but I've seen like modifications you can do to your 3D printer. So, of course, you have some sort of control box in which you can input files, usually like on an SD card or a USB, and then some sort of screen. Some of them have dials and buttons. Some of them are touch screen that you can use. And then you've got where the power comes in, going out to the plug. And that's just like any computer. It's got a motherboard in it and chips that control all of these different motors. And you also have a fan in here that is trying to keep everything cool. So, that, in a nutshell, is basically what 3D printing is and tries to be. And it is a lot of fine-tuning. It is a lot of depending on the type of filament that you get, because you want your filament to be, as much as possible, the exact same diameter. You can get cheaper filament, but it's not going to be as consistent in its diameter, which can cause problems if you are extruding and you're used to extruding at this width, but coming on down the line, you have thicker filament and then it gets back down to being thin again. It's going to clog things up. So I have on order 3 different types of filament that will be coming in the next few days, and I'll be doing an unboxing of those when I get ready to print. And I'm going to be seeing the difference between the qualities. All 3 of them have gotten really good reviews, so it may come down to just my personal preference. Because there is another thing that you need to watch out for, and that is moisture. Some plastics and filament really like to suck up moisture out of the atmosphere than others. So for those type of really, really finicky filaments, you keep them in a box. And you usually put some sort of desiccant or drying agent in the bottom of the box, and you seal it at the top. When you're not using it. And that keeps your filament dry. Actually, it should be probably coming off the bottom. Because some people actually have a small little port here on the side, and they bring the filament out of the box and go to the 3D printer, keeping it as dry as possible. If you live in hot, humid areas, maybe in a garage that doesn't have the best air conditioning, this is probably a bigger problem, especially when trying to print some of the more finicky types of filament. If you're in a drier climate, it's not going to be as much of an issue. So that is something I'm going to have to experiment with. The type of filament I'm starting out with is very basic. It does absorb some moisture, but it is not as prone to it as some other types of filament. And another thing you may see is you may have a 3D printer here. And you may see that 3D printer is put inside of an enclosure and they do that in order to keep the temperature consistent inside of the area that you're printing. Some filaments are very finicky. If you have like an air conditioner and it's blowing air onto the model and it is making this filament too cold as it's coming out of the printhead, it's not going to get as good adhesion and you're going to have some problems. So one of the other things I'm looking at eventually getting is some sort of enclosure just to keep the temperature moderated and keep any drafts from coming in and playing around with the temperature too much. But I have to research that a little bit more, and once I get my printer, I will be testing that out as well. So that is the basics as far as I know them right now. And you can go online and there are tons of tutorials and there are tons of forums with people really helping each other out. It's a really nice community that I've discovered. But for every problem, there's usually about 5 different potential things you can try to solve it. So this is a hobby for the patient until you get it dialed in. So we're going to be finding out how patient I am for sure. So next video, I'm going to be talking about other aspects of 3D printing. I want to show you guys the space I'm setting up for it. It's small right now, but it'll be a good starting space for getting going, getting everything set up, and then learning what I need to do from there. I need to run some electricity to the area. I need to prep it in a few other ways. So I want to make some videos about that as well. Hopefully, the printer should be shipping to me in the next few weeks. And it's going to take a while to actually get here. The printer that I bought was from a company called Creality. And they ran a Kickstarter campaign on one of their newer printers that is specifically targeted to people who are printing 3D printing for the first time. Because one of the things I didn't mention is this bed and making sure that this bed is 100% horizontal to the plane of travel that the printhead is moving back and forth on. And this is a printer that levels the bed automatically. which is a huge time saver because getting to level the bed by hand can sometimes be a pain and something that you needed to do every 3 to 5 prints. So it's a brand new printer. Backed it on Kickstarter like a ton of other people. They did very well with it. And so they are manufacturing them as we speak, and hopefully mine will be shipping soon. I was somewhere in the first 2,000 some that backed the project out of eventually like 10,000 some. So I hope that means that I will be receiving it soon, although there's some other things that may affect when I actually receive my printer, but I'm hopeful that it will be at least within a month, maybe 4 or 5 weeks. So until then, I'm making my preparations. I have made my preparations by educating myself as much as I can in the basics so that when it gets here, I can start to dive into the minutiae of that particular printer. The other way in which I'm preparing is not only setting up my little space for it, but is in learning how to actually create objects in 3D for this thing to print. And that will also be the subject of a video or two. So I'm very excited, even though I'm trying to speak in a very soft ASMR voice. I am very excited. And I hope that you have enjoyed. I hope you've learned a little bit. And if you have any comments or any suggestions, or if you have a 3D printer, let me know your experience with it. Maybe some tips and tricks that you've learned with printing. I'm trying to get all the knowledge that I can about this. And if you haven't subscribed, please do. You can follow along this journey with me into DIY ASMR 3D printing. It's a lot of letters in one number. So, I'll see you guys in my next video. Thanks. Bye.